Alright, if it's the beginning of 7th hour right now, and if you're trying to look for a video and you're looking for one that's up there, hopefully this one will load. The previous one is giving me issues. I think it's probably the network connection. But anyways, we were going to start with number 16 here. And 16 says to integrate 1 minus the cosine theta over theta minus the sine of theta, all that stuff cubed, d theta. Well, I'm going to let u equal theta minus sine theta. And that means that du is going to equal 1 minus cosine theta d theta. So this integral becomes 1 over u cubed du, which is u to the negative 3 du, which is negative 1/2 u to the negative 2 power plus c. Now substituting back in, negative 1/2 theta minus sine theta to the negative 2 power plus c. Or something equivalent to that would be fine. Number 17. Again, they want us to integrate this tangent to the 4th power of x secant squared x dx. Now, hopefully you realize that the derivative of tangent is secant squared. So we just let u equal tangent of x. Du equals secant squared of x. I wish there was a easier way I could just tell you to look at this and say, oh, tangent secant squared. Sometimes experience is the only thing that matters. U equals tangent of x du, then is secant squared x dx. So then our integral becomes u to the 4th du, or 1/5 u to the 5th plus c, which is 1/5 times the tangent to the 5th power of x plus c. Okay. Moving on to number 18. Oof, look at number 18. I'm sure many of you are thinking, Mr. Hintz, you bad word, you. How could I even think to give you a problem like this? Well, let's remember that 1 minus sine squared is cosine squared of x, and that's over cosine of x dx, which means that simplifies down to the cosine of x dx, which makes this sine of x plus c. Okay? All right. Number 19. Right? 1 over. I'm going to write that x to the 1/2 power times 1 plus x to the 1/2 power all squared dx. Now I'm going to let u equal what's inside the parentheses. And that's going to make du equal to positive 1/2 x to the negative 1/2 dx. Well, 1 over the square root of x is x to the negative 1/2 power. I don't have a 1/2 here, so I've got to multiply each side by 2. So 2 du equals x to the negative 1/2 dx. So now we're going to rewrite this thing. 2 times the integral of 1 over u squared du, which becomes 2 u to the integral negative 2 du, which is negative 2 u to the negative 1 plus c, which is negative 2 times 1 plus x to the 1/2 power raised to the negative 1 plus c. You can leave it like that. If you want to write it negative 2 over 1 plus x to the 1/2, or 1 plus the square root of x plus c, that's fine. Equivalent is fine. Otherwise, you can leave it like this. Let's see, we were skipping number 20. Oh, 21 is a good old-fashioned fill in the blank. If f of x is continuous on AB and capital Fx is the antiderivative of fx on interval AB, then the integral a to b of f of x dx equals f of b minus f of a. Okay. 22, we've got some integral properties here. They tell us the integral from 2 to 5 of f of x dx is equal to 4, and the integral from negative 1 to 2 f of x dx equals 6. Now part A, they're looking for 1 to 2 on here. The integral from 2 to negative 1 of f of x dx. Now, you notice the limits of integration are switched here. So what we would have to do is put a negative sign out in front of the original. So instead of equaling 6, it's negative 6. For b, it's the integral from negative 1 to 5 f of x dx. Well, if you look, we go from negative 1 to 2 and then 2 to 5. So what we would simply do is go 4 plus 6 equals 10. Add the two together. For c, they're trying to trick you. Integral from 5 to 5 of fx dx is basically what they're doing is telling you to find the volume of a line, and a line doesn't have volume. So that's 0. In part D, essentially what they want you to do is take your answer from part A, which is negative 6, and add it to the integral from 2 to 5, which is 4, and that gives you negative 2. Alright. Moving on to number 23. We want the integral from 0 to 1 of 3x times the cubed root of x squared minus 2 dx. I'm going to let u equal x squared minus 2. Then du is going to be 2x dx, or 1/2 du is going to equal x dx. Well, there's an x. I can bring the 3 out in front, and I've got that 1/2. So now I can rewrite this integral as 3 over 2 times the integral u. And instead of the cubed root, I'm going to write that to the 1/3 power du. And that's going to give me 3/2 times. I add 1 to 1/3 and I get 4/3. That means I've got to multiply by 3/4. So now I've got 9 over 8 u to the 4/3 power. So that becomes 9 over 8 times x squared minus 2 raised to the 4/3 power. And we're going to evaluate that from 0 to 1. This is a great time to get out your calculator. And when I do this, I got negative 1.710. Okay. Okay. All right. Yep. I'm willing to be proven wrong on that one. But that's what I got. 24. 24 is a tricky one. And instead of writing that the square root of x, I'm going to write that x to the 1/2 power dx. And now I'm going to distribute. So I've got 2x to the 1/2 minus x 2 plus 1/2 becomes 2.5, or that I'm going to write that 5/2 dx. Now what we can do is integrate each of these things individually. And I get 2 times 2/3 x to the 3/2 minus 2/7 x to the 7/2. We evaluate this thing from 1 to 4. And again, this is a great time to get out your calculator, and I got negative 26.952. And again, I'm willing to be proven wrong on that. I'm going to give these things a second shot here in a little while. We're skipping 25. So that moves us on to 26. And 26 is the integral from 0 to pi of x times the sine of x squared dx. Well, let's let u equal x squared. Du is going to be 2x dx. 1/2 du is x dx. So this thing becomes 1/2 the integral sine of u du, which is 1/2, let's go negative 1/2 cosine u, which is negative 1/2 cosine x squared from 0 to pi. And again, this is another one that I get my calculator out and I got negative 0.951. Okay. And again, I'm willing to be proven wrong on that one. And we'll stop right here. We'll do 27, 28 on the next video and see how that goes.